All right, brace yourselves, and you're going to want to redo these and practice and pause and try things out. These skills only come through a lot of practice. Here you go. Remember that we want to express everything in reduced row echelon form. What that means is we're looking for the answer to be in the form of 1001 and then some numbers here at the end that magically happen because of row operations. So we'll go ahead and note that there's a 0, 0, and a 1. If we do row 1 and switch it with row 2, we get this setup with the 0 and the 0 and the 1 in the correct places. This 2 needs to become a 1, so we will propose that we do half of row 1 and put it back into row 1. Row 1 is as follows, and if we multiply everybody by 1/2, we'll note that this becomes a 1. This, of course, is a 0, and then half of 10 is 5. This then becomes our new row 1. Row 2, of course, was 0, 1, 4, and then we're done with this problem.
Most impressive.
When we look at part B, we'll note that the 1 and the 0 and the 1 are in their correct positions. It's this 1 that needs to become a 0. I'm going to write something down, and you're going to need to probably pause and think about what it means. Here we go. It means I'm going to add row 1 and row 2 together. However, I'm going to first multiply row 2 by negative 1s and then add that to row 1. Let's do some side work. Here is row 1. Here is row 2. If I multiply row 2 by negative 1, I get that. Now I'm going to add them. So 1 minus 0 is 1. 1 minus 1 is 0. 4 minus 6 is negative 2. This is now my new row 1. So let's try this again. I take row 1 and I add it to the row 2, but row 2 I actually change everybody to negative 1. How did I know to multiply by negative 1? Well, this already is a 1. So I multiplied by the opposite to go ahead and get that to cancel out. So the trick here is I need to make sure that this number and this number are opposites of each other, so they end up canceling out at some point, like they did right now. Once I go ahead and do that and I add them up and down, like we do in first grade, then this becomes my new row 1. Row 2 was the same. My new row 1 is 1, 0, negative 2. And we're done with this problem.
I think I need a hug.
You're going to want to rethink and rework part B for sure. This is the third row operation rule. This is the most powerful one because it does so much for us. So get used to this one. We're going to do some more examples that also incorporate this, but you might want to pause and reflect at this point before we get too much into your head. C is looking not that great. So we have a 0 and a 1 in place, but this is not looking good at all. So let's go ahead and begin by getting a 1. We'll do 1/2 row 1, put it back into row 1. I'm going to take some confidence in your mental math and hope that you're comfortable with me doing this. So half of 2 is 1, half of 2 is 1, half of 4 is 2. This is your chance to shine, for you to prove yourself to yourself. We need to make this 1 become a 0. What could we possibly do? Maybe pause. Go ahead. Try it out ahead of me. Do we always do this step, Mr. Over, like that? No, we don't always do this step. Sometimes we multiply by something else. This is how it works out in this case. And we are going to put it into row 1 because I need that 0 to be in row 1. So what is my row 1 looking like right now? It's a 1, 1, 2. My row 2 is a 0, 1, 6. I need to go ahead and change all the signs in row 2 because that's what I'm saying to do. So it's going to be a negative, negative, negative. We go ahead and add them up. 1 minus 0 is 1. 1 minus 1 is 0. 2 minus 6 is negative 4. This becomes my new row 1.
Most impressive.
We have, of course, our 1, 0, 0, 1, and this is now expressed in reduced row echelon form. I want to apologize because I probably didn't leave you enough room on your notes at this point. You might want to go ahead and get a separate sheet of paper, staple it to this because you don't want to be stingy with your space. For part D, if you want to take a moment and try it without me, you'd be surprised how accessible this matrix is. You might want to consider that fancy step, but not make it too fancy. You could get this done in 2 steps if you wanted to try it out. Otherwise, I'm going to propose we do this. Row 1 plus row 2 and put it back in the row 1. Again, I want this to become 0. But note that this time, this number is the opposite of this number, so they're going to cancel out. I don't have to do any negative 1 multiplying. This will take care of itself really nicely. So here's row 1 the way it is right now. Here's row 2 exactly the way it is right now. I'm not doing anything extra to it because it's ready to go. If I just add them up and down, that's a 1, a 0, and a 10. That is quite lovely. So we have the new row, which is 1, 0, 10. And this is almost done. To get this negative 1 to become a 1, we would multiply negative 1 to row 2 and put it back into row 2. Doing that, of course, change these signs. So this will become a negative 0, a positive 1, and a negative 6. And this is our final answer. Not bad, right? Not bad. E, F, and G are some of the bigger problems in this class when it comes to reduced row echelon form. So you'll know that there aren't any zeros in place for E or G. That means we have a lot of work to do. And that will be our primary job right now, is to get zeros. Get zeros first. So we want to get, that 1, 0, 0, 1. Don't worry about the ones right now. What we want to make sure that we get are these zeros in place. Because if we get these zeros in place, then everything else becomes easier. May I propose we go ahead and make this 0. And we don't just make it a 0 because we want to. And we don't multiply by 0. And we don't add by 0. And we don't subtract by 0. We have to do a row operation. Okay, and so in this case, maybe we will do row 1 plus row 2 and put it back into row 2. Now the question becomes, I need to have one of these two be opposite. So I need to multiply either row 1 or row 2 by a negative 1. The question is, how much work do you like to do? Because if you like extra steps, it doesn't matter which one you do. It'll work out no matter what. However, if we want to save ourselves some more trouble, let's consider the following. If I multiply row 2 by negative 1s, and then I add them up, I'm going to get a negative 3. And now I have to deal with a negative 3. So rather than do extra work on me, I'm going to go ahead and decide, let me multiply row 1 by negative 1. And that'll give us less negatives to deal with in the future. Here are row 1 and row 2 as originally put forth in this matrix. We are going to go ahead and we decided to multiply row 1 by negative 1. So that makes us a negative 1, a positive 1, and a negative 2. Adding up and down, we have negative 1 plus 1 is 0. 2 plus 1 is 3. 3 minus 2 is 1. Quite nice. So we ended up with no negatives. This becomes my new row 2. So great, we picked up a 0. We lost a 1 in the process. Oh, actually, we never had a 1. So we're fine. We picked up a 0. Great. And we have this 1 appear. Great. Next, I'm going to suggest we get this to become a 0. I know some of you are thinking, well, Mr. Rover, why don't we just go ahead and multiply this by 1/3 to get a 1 out of this? We could do that, but how comfortable if you do 1/3 on this, 3, right? If we go ahead and divide this by 3 and divide that by 3, yes, it becomes a 1, but now you have to deal with a 1/3. And I know you're in algebra 2, but I'm not quite sure how many of you are comfortable doing 2 plus 1/3. Okay, so if you want to avoid unnecessary negatives and unnecessary fractions, then I would suggest let's not make this a 1 yet. Let's focus on making this a 0. So, how about this? Let's try 3 times row 1 plus row 2. Put it back into row 1. Mr. How do you know what row to put it back into? Well, I want a 0 in row 1. So all this work that I'm doing over here is to get that 0. And if I get that 0, I want to put it where it belongs in row 1. If we go ahead and write R1 and R2 the way they are, I have this. If we multiply row 1 by 3, right, that's 3 times 1, that's 3 times negative 1, that's 3 times 2, we get 3, negative 3, and 6. And then we add these up and down because we said we're going to add them. That's 3, that's 0, and that's a 7. Remember, the purpose of this step was to get a 0, and we got this 0 right here. That is now my new row 1. We have the two zeros. Now at this point, I hope it's pretty smooth from here that you wouldn't need me to do this for you. But we would go ahead and do, because this 3 needs to become a 1, I would take the reciprocal of that. That's 1/3. So 1/3 row 1, put it back in the row 1. And over here as well, this needs to become a 1, this position. So we're going to do the reciprocal of that 3, which is a 1/3 again, row 2, and put it back into row 2. Doing that for each of those respective rows, we get the final answer of 1, 0, 7/3, and 0, 1, 1/3.
I think I need a hug.